Welcome, y'all. Back to some more geometry. We're looking at our last lesson of this semester, talking about trapezoids and kites. So let's kind of build up to this. So with this whole time, we've been talking about rhombus. No, full rhombus, of course, but a quadrilateral. So quadrilateral is just a four-sided figure. It doesn't matter what it looks like. Ooh, it's a horrible quadrilateral. Let's clean that up a little bit right there. Good, beautiful, beautiful, beautiful. So it's quadrilateral, just four-sided figure. From there, we are able to build on to come up with the parallelogram. Parallelogram. And there's a bunch of rules about parallelograms. Opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, the diagonals bisect each other, and then consecutive angles are supplementary. From there, we came up with the rectangle. Well, we didn't come up with it, but it came to be a rectangle and then a rhombus. A rhombus. And then one crazy night, the rhombus and the rectangle had a love child named a square. Okay, well, a trapezoid and a kite both come off straight from the rectangle. They have nothing in common to these right here. You have a trapezoid, and then from there you have a kite, and we will talk about those today. So they're a little bit different from the other ones. They have no relation to them besides they're like cousins or something like that, you can call them. All right, start with the trapezoid. So trapezoid is a quadrilateral, but with exactly one pair of parallel legs. So unlike all these have some similarity, but they're not related in this case compared to what the other ones are as being part of parallelograms. They have one set of parallel legs. Those are your bases. Those are the base. The other two legs of the trapezoid are just what we call the legs. They're just legs. Now, to be more specific, on an isosceles trapezoid, remember, we've seen this word isosceles before. We saw it with triangle. An isosceles triangle meant that it has at least two sides that are congruent and the two base angles are congruent right here. So similar thing right here. In an isosceles trapezoid, you have two bases. The two legs are congruent if the two legs are congruent. Again, there's trapezoids. We're just the only thing to be a trapezoid is the opposites. The base sides are parallel. But in an isosceles trapezoid, if the legs are congruent, then the base angles are congruent. But check this out. It has two sets of base angles, both on top and on bottom, because it has two base sides right there. So as we go through this, we say that, hey, trapezoids. If it's an isosceles trapezoid, then like we said, the base angles are congruent. And the way you'll know is, one, they'll tell us, hey, these are congruent to each other. So then these two angles, they share a base, they're congruent to each other. Or these two angles, they share a base, they're congruent to each other. And again, if the trapezoid has at least one pair of congruent base angles, then the whole thing is an isosceles triangle. So vice versa, if we don't know it's a trapezoid, but we find out that the base angles are congruent, then the whole thing is an isosceles trapezoid. Now, an isosceles trapezoid, the trapezoid is isosceles if and only if the diagonals are congruent. So it's similar to a rectangle, the whole diagonals are congruent to each other, but not similar to a triangle. It does not bisect each other. They don't bisect each other. They don't cut each other half. It's pretty obvious. This side right here is way longer than this one over here. But when it is isosceles, this and this are congruent, and then these two smaller ones are congruent to each other. Again, this is specific for isosceles. You'll see this is probably the most common type of trapezoid, an isosceles trapezoid, but there's other ones that we'll see here in a bit. Now, the mid-segment of a trapezoid is the middle part of the whole thing. And when you connect the mid-segment of the sides, it splits those sides in half. So let's look at this. Let me fix that right there a little bit. All right. So the mid-segment, again, is the middle of the sides. So that means it splits this and this into equal parts, and this into equal parts. Not necessarily equal to each other, but it is equal on each side, two smaller segments. But this mid segment can also be found by doing this. You take the mid segment is equal to base 1 plus base 2 divided by 2. So in this case, these are the bases right here. So to solve for x here, we would take 22 plus 42 divided by 2. So add them up, you get 64 divided by 2, we get 32. So this mid-segment is 32. But also, let's kind of think a little more non-mathematical, but pattern recognition. The difference between here and here is 20, so halfway will be 10. So this will be 10 more, and then this is 10 less. So the same idea is kind of true here. Now, mathematically, the way we will work this particular problem down here out, let's do the non-math way first, and then we'll do the math way first to double check ourselves. So again, from 12 to 15, that's 3. So that means this will be 3 units less from here to here, making this should be 9. Well, let's double check that. So mathematically, we'll say mid-segment, which is 12, equals base 1 plus base 2 all over 2. So we'll multiply both sides by 2 here. We get 24 equals x plus 15. Subtract the value of 15 from both sides. What do we get? 9. So yeah, either one will work here. Now these are equal to each other. That's equal to that, and that's equal to that. But the difference between, this is the length of 15, the length of 12, the length of x. All right, so that's all trapezoids. Now let's move on to kites. So kite is, again, it's based off a quadrilateral, so it has 4 sides, but it has exactly 2 pairs of consecutive congruent. Let me move that around because it's looking all weird. Consecutive congruent sides. So what that means is, and it's hopefully, looking at this, you can see which side. This side is congruent to this side, and then these 2 long ones are equal to each other. So these 2 sides are equal to each other. These 2 sides are equal to each other. But unlike a parallelogram, opposite angles of a kite are not congruent or parallel. The opposite sides are not congruent or parallel, but it's the consecutive sides that are congruent right here. So again, if your quadrilateral is a kite, the diagonals that you will draw here, let me get this little straight tool right here. They're perpendicular to each other. They'll form a right angle, even though it's kind of crooked. It forms a right angle right there. It makes 4 right angles here. So when they intersect, it forms 4 right angles. And not just that, when you do this, there's one pair. The longer diagonal splits the shorter diagonal into 2 equal parts. So these 2 parts are equal to each other. These are not, but these are right here. Also, let's clear that up a little bit. Ooh, let me fix that. Like it was. Good, good, good. But also, according to this last theorem down here, it says there is exactly one pair of opposite angles congruent. It's these 2 angles right here. These 2 are congruent to each other. Okay, these are not. So let's kind of do some work here, similar to what you'll see. So here they're telling us that this is a kite, and we're looking for angle X, Y, Z. So we're looking for this angle right here. It's really weird. There you go. This angle down here. Now, like we said, this is still quadrilateral, so it still adds up to be 360 degrees. Because remember, to find the sum of interior angles of quadrilateral to the number of sides, oops, there you go, minus 2 times 180. We get 2 times 180, we get 360. All right. Now, this is 73, this is 121. What would Z be? Yeah, it'll also be 121 because these 2 are congruent to each other. So we add those up all together. We get, let me get my calculator. It's been a while. All right, we get 121 plus the 121 plus the 73. We get 315 between those 3. And we just subtract that. We get 45. So this is 45 degrees down here. All right, next one says that MNPO is a kite. MX, this right here, is 8. And O is 12. The whole thing is 12. What is MN right here? So if the whole thing is 12, and again, this splits it in half, what is this right here? It's a 6. We're looking for this. This is a right triangle. So if we don't remember what right triangles, and we kind of mentioned this in the last section, we're going to be doing the Pythagorean theorem here. We're looking for this. In this case, this is our hypotenuse, the part we're looking for. So we'll do 6 squared plus 8 squared equals x squared. So there you get 36 plus 64 equals x squared. Add them up, you get 100 equals x squared. And to get rid of the square, you square root it. 10 equals x. So this side right here is 10. You'll do this a few times in your homework, but if you have any questions, y'all, feel free to ask. Y'all have a great day.